Hi friends, myself D.K. Narale, working as a assistant professor in Gopal Krishna Gokul College, Kolhapur. Today we will discuss inorganic chemistry paper number 13, inorganic reaction in inorganic chemistry paper 13 to study the first topic inorganic reaction mechanism. Outline of this topic is in this topic contain the introduction, classification of mechanism. This classification of mechanism contain association mechanism, dissociation mechanism, interchange mechanism, and the rate determining step. Next point is the SN1 and SN2 reaction for the inert and labile complexes. Next point, mechanism of substitution in cobalt-3 octahedral complexes and trans effect and its theories. And last point is application of trans effect in synthesis of platinum 2 complexes. Introduction of this introduction of this chapter contains the reaction mechanism means the is path of reaction from reactant to product, that is the kinetic study, that is reaction change from stereochemical aspects, activated complex, and the rate of reactions. Actual classification of the substitution reaction is two types reaction: electrophilic substitutive reaction and nucleophilic substitution reaction. In metal complexes, the central metal atom act as the electrophilic reagent, and the ligand act as the nucleophilic reagents. In classification of substitution mechanism, two types of mechanism. One is the intimate mechanism and the second is stoichiometric mechanism. In intimate mechanism, the dissociative and associative mechanism, but in stoichiometric mechanism, in interchange dissociative mechanism and interchange associative mechanism. First, total 4 type of mechanism. First is dissociative mechanism. Dissociative mechanism is the SN1 mechanism. Every dissociative or associative mechanism contains two-step reaction in this mechanism. In dissociative mechanism, Ml5x plus y, then the product gives complex is formed Ml5y plus x. This first step in dissociative mechanism, 2 steps. In first step, dissociation of x to yield a 5-coordinated intermediate. Means dissociative mechanism mainly first a 6-coordinated complex is converted into intermediate form 5-coordinated complex. Then the again incoming ligand react to intermediate 5-coordinated complex, then converted into the 6-coordinated complex. In intermediate form in the first step is 2 types of geometry is formed. First is a trigonal bipyramidal and second is square pyramidal. First step is the slow step, that is slow step means the rate determining steps. Step second, coordination of y to the Ml5 intermediate, Ml5 plus y, then fast reaction Ml5y. This reaction does not depend on the incoming ligand y. Rate of whole dissociative mechanism, rate of reaction is equal to K into Ml5x, that is the dissociative mechanism. SN1 nucleophilic substitution reaction is the first order reaction. In pictorial picture, in energy profile diagram or in this blue shade octahedral complex, then the red ball is incoming to the blue position replacement of blue, that is the incoming ligand is red color and blue is leaving ligands. In the energy profile diagram shows the first reactant then converted into this activated complex, then converted into intermediate is short lived, and then the converted into product. Example of dissociative mechanism is hexacarbonyl tungsten 2 gives pentacarbonyl tungsten, then the pentacarbonyl tungstens with react with triphenylphosphine to gives the pentacarbonyl triphenyl tungsten. The energy profile diagram shows reactant then converted into activated complex, then converted into intermediate, and again converted into activated complex to form a product. In associative mechanism, mainly first bond making, then bond breaking. In this mechanism, 6 coordinated complex converted into 7 coordinated complex, and then 7 coordinated complex converted into 6 coordinated complex. In two-step mechanism, first step is the Ml5X plus Y converted in slow step reaction to converted into 7 coordinated intermediate. That is the two types of geometry, capped or octahedral wedge, and next geometry is pentagonal bipyramidal intermediate is formed. Then cleavage of the leaving ligand, that is the MX bond break and then converted into Ml5Y plus X. That is the rate is depends on the first step, that is rate is equal to K into Ml5X into Y. Example of the radioactivity is C14 monitor the overall reaction by cyanoligands, tetracyanonickelate plus radioactive monitor C14 cyano group reacts to form a pentacyano and then again form a tetracyano plus cyano ligands. In energy profile diagram, R reactant converted into activated complex, then the converted into intermediate and activated complex to form a product. Third is C point, the interchange mechanism. Interchange mechanism contain, that is the stoichiometric mechanism. Both interchange dissociative mechanism and interchange associative mechanism involving the interchange of X and Y without definite intermediate. In interchange dissociative mechanism, in the transition state, bond breaking is more important than bond making. In similar ways, SN1 shows first the incoming ligand X leaving group is first leave, that is X is leave, that is then the bond is making. The activation energy is determined by mx bond strength. In second, interchange associative mechanisms, in the transition state bond formation is more important than the bond breaking. In activation energy is determined by crowding in the transition state. Energy profile diagram of the interchange associative and dissociative mechanism is reactant, activated complex, short-lived intermediate, then short-lived activated complex, and the product. Last, the rate determining step. In rate determining step, 3 types of mechanism: dissociative, associative mechanism and the interchange mechanism. In first, for the dissociative mechanism, the first slow step is the rate determining step in the case of octahedral complexes. That is, first step in the dissociative mechanism, ml5x is converted into ml5 plus x, that is slow step. The rate determiner by the ml5x, rate is equal to k into ml5. Only one reactant involved in the rate of reaction, that is the first order reaction, not depends on the y. For associative mechanism, formation of the intermediate ml(n)xy intermediate, that is association of complex with incoming group by bond formation, is the rate determining step. That is, ml(n)x plus y incoming ligand to form intermediate ml(n)xy slow step. That is, the rate will be depends on the incoming ligand plus this complex. That is, rate is equal to k into ml(x) into y. In third, in interchange mechanism, rate of formation of activated complex depends on either rate at which the mx bond breaks for the interchange dissociative and the rate which the my bond form for the interchange associative mechanism. According to Wilkins mechanism, first step form a encounter complex ml(x) plus y is equal to ml5xy to form the encounter complex. Then ml encounter complex converted into product of slow step. The second step is the rate determining step. Next point is the SN1 and SN2 reaction for inert and labile complexes. Labile complexes, that is the reaction within 1 minute goes, that complex is, that first substitution reaction is called as a labile complexes, and the reaction goes to slow substitution reaction, then the complex is inert. Most of the labile complexes are SN2, that is the associative mechanism, and inert complex most of the SN1, that is dissociative complexes. In d-electronic composition of inert and labile is the D3 low spin, D4, D6 and D8 are the inert complexes. D-electronic complexes are the inert, and the intermediate is D8, and labile is the D1, D2 and low spin D4, D6 and D7 and D10 are the d-electronic configurational d orbitals are the labile complexes. SN1, that is the unimolecular nucleophilic substitution reaction. In dissociative mechanism, steps are, it indicates unimolecular nucleophilic substitution, that is first order reaction. In this mechanism, mx bond is fully broken before the formation of my bond, and intermediate is detected in the rate determining step, in which the central metal has lower coordination number than it in the reactant. In simple reaction, then the two-step mechanism. First step, these 6 coordinated complex is converted into elimination or cleavage of mx bond in first step, that is slow step, to converted into 5 coordinated intermediate. Again 5 coordinated intermediate reacts with incoming ligand y, then to form 6 coordinated complexes. Rate is equal to k into ml5x. Mechanism goes to, in SN1 dissociative mechanism, first of all cleavage of leaving group X to form a trigonal bipyramidal intermediate and square pyramidal intermediate. Then incoming ligand reacts with to this 5 coordinated complex to form a 6 coordinated complex. Most of the D4 D7 cases, that is SN1 mechanism go through by this trigonal bipyramidal geometry. That is the energies square pyramidal shows less energy required, goes to this ways mechanism. SN2 biomolecular nucleophilic substitution reaction. Intermediate at the rate determining step has the higher coordination number than that in the reactant. The MY bond is fully formed before the breaking of MX bond, and it is the second order and also involved two steps. First step is 6 coordinated complex reacts with incoming ligand Y to form a 7 coordinated complex. Slow step reaction with unstable 7 coordinated complex is formed. Then unstable 7 coordinated complex cleaves the MX bond to form a 6 coordinated complex. That is, rate is depend on the first step, that is rate is equal to K into ML 5X into Y. SN2 associative mechanism. In associative mechanism, 6 coordinated complex reacts with the incoming ligand to form two geometry. One is the pentagonal bipyramidal and second is octahedral wedge. Octahedral wedge shows less energy, that goes to this form cleavage of X, then converted into 6 coordinated complex, and octahedral wedge is favor for the SN2 associative mechanism. Thank you for listening and watching.